Welcome to This Explainer. Look, if you're keeping tabs on global manufacturing right now, you know the landscape is shifting at absolute lightning speed. I mean, as we barrel toward 2026, supply chain resilience isn't just some corporate buzzword anymore, it's literal survival. So today, we're unpacking what might just be the ultimate procurement advantage, Waterjet technology. We're going to see exactly how mastering this tech gives buyers a massive edge when it comes to flexibility, cost savings, and getting the absolute most out of your materials. You know, there's a really good reason people call this the universal tool of the factory floor. Normally, in that traditional manufacturing mindset, the second a new material requirement comes down the pipeline, there's this immediate panic about capital expenditure, right? Like, oh no, do we need to buy a new laser? Are we going to have to retool the whole line? Well, the sheer beauty of Waterjet technology, and honestly why it totally flips the status quo on its head, is that buyers can switch material types instantly. You can literally go from cutting solid titanium to slicing through foam without reinvesting a single dime in new machinery. It is an absolute game changer for supply chain versatility. Okay, let's dive into this. Here's a super quick roadmap of the material categories we're going to conquer today. We'll kick things off with the core concept, then punch through the heavyweight, fragile, future, and volume classes before wrapping it all up with the audit. First up, Section 1, the core concept. We really need to lock in the fundamental technological advantage that makes all this sourcing magic happen. And that big advantage? It all comes down to totally avoiding the heat-affected zone, or HAZ for short. Let's demystify that jargon real quick. When you use laser or plasma cutting, you are literally melting the material. That extreme heat alters the mechanical properties of the metal right at the edge of the cut. It makes it brittle and unpredictable. But a waterjet, it's completely different. It uses a non-thermal, high-pressure erosion process. It's what we call cold cutting. And eliminating that HAZ means your raw materials preserve their mechanical integrity perfectly. So you get to completely skip those super expensive secondary heat treatments and edge grinding steps. All right, moving on to Section 2, the heavyweight class. This is the absolute largest segment of the waterjet market, focusing entirely on industrial metals. Look, steel is the absolute backbone of B2B sourcing, right? Now, lasers are incredibly fast when you're dealing with thin sheet metal, but the second things get thick, they lose a massive amount of efficiency. But waterjets? They can slice through stainless steel plates up to 150 millimeters thick without even breaking a sweat. And because it's a cold cut, like we just talked about, it leaves this beautifully smooth, burr-free edge, which means the parts hitting your receiving dock are actually ready to weld immediately. Zero secondary finishing required. For a procurement manager, cutting out those extra processing steps directly and massively lowers your total cost of ownership. Now let's contrast that with aluminum. Sourcing aluminum, especially those 6061 or 7075 grades used in automotive and electronics, that presents a really unique challenge. Aluminum is highly reflective and extremely thermally conductive. So when you blast it with a fiber laser, all that heat causes microcracking. But a waterjet, it just completely ignores light absorption. It literally just powers right through. That means you get pristine parts without any of those hidden structural flaws caused by heat-based methods. Plus, since aluminum is a softer metal, waterjet speeds are incredibly fast, which massively shrinks your lead times on those high-volume RFQs. Then, of course, we have titanium. Incredibly expensive, highly specialized for the medical and aerospace sectors. You absolutely cannot afford waste here. And this brilliantly illustrates how a narrow cut width literally translates to saved budget on expensive raw aerospace materials. A waterjet has a kerf, which is just a fancy word for the width of the actual cut, of about 1 millimeter. That tiny kerf allows modern software to do what's called ultra-tight nesting. The parts are practically jigsawed together, placed mere millimeters apart on the raw sheet. You end up extracting significantly more parts from a single pricey titanium sheet than you ever could with traditional milling. Now, you might want to pause and take a mental picture here because this is your ultimate procurement cheat sheet. It maps out the high-level overview of everything we're covering, from metals all the way down to plastics, showing the best cutting method, max sourcing thicknesses, and exactly what your priorities should be when writing an RFQ. So we've just covered metals, where edge quality is the big priority. Let's move down a row and check out some of the more specialized categories. Which brings us to Section 3, the fragile class. Let's get into the architectural sourcing logic for stone, glass, and ceramics. Okay, if you are sourcing custom inlays or big marble countertops, you really need to know this insider secret. Fragile stones like marble, they can be completely destroyed if the machine pierces the slab at full pressure. I mean, it'll literally turn your very expensive slab into very expensive gravel. No way you want that. So when you audit a stone supplier, you absolutely must check if they have dual pressure piercing or low pressure capabilities. A quality supplier will gently pierce that stone at a low pressure before they ramp up to full cutting speed. If they don't do that, you are just going to be paying for shattered marble. Glass definitely brings its own set of rules to the table. Waterjets are actually phenomenal for complex things like ballistic glass or intricate stained glass for hospitality projects, but, and I need to issue a massive red flag warning right here, never attempt to waterjet tempered glass. Tempered glass is literally designed to shatter into a million pieces under stress. If your project absolutely requires tempered glass, you have got to get the specific order of operations right to avoid a total project disaster. You must have your supplier cut the glass to the exact size while it's still in its raw state and only send it off for tempering after the cut is finished. All right, moving right along to Section 4, the future class. We're pivoting to the big macro trends in EV and drone lightweighting with advanced composites and plastics. When you're sourcing carbon fiber, you run into this absolute structural nightmare called delamination. Basically, it's the separation of the material's layers, and it's usually caused by the sheer heat and heavy vibration of traditional drilling or sawing. But waterjet cutting? It solves this instantly. Because it applies zero heat and very little downward vertical force, the structural integrity of the carbon fiber remains perfectly intact. If you are sourcing for the EV or drone sectors, this is absolutely non-negotiable. And when we talk about thick engineering plastics, things like UHMW, polycarbonate, or acrylic, using a waterjet isn't just about precision anymore. It's about compliance. Sourcing these materials via laser can produce some pretty nasty toxic fumes and smoke. But waterjet is a cold-cutting, water-based process. It produces zero hazardous gases. As we march toward tighter and tighter regulations for 2026, sourcing these plastics via waterjet is a critical green alternative that directly supports your corporate ESG goals. Let's keep this momentum going right into Section 5, the volume class. We're transitioning from high-tech composites to the massive volume demands of soft materials. So up until now, we've basically been talking about abrasive waterjet, right? That's where crushed garnet is mixed with the water to erode those really hard materials. But when you are sourcing things like industrial gaskets, seals, rubber, or foam, suppliers actually change the machine setup. They completely remove the abrasive garnet. What's left is this hair-thin, supersonic stream of pure water that just slices through soft materials with incredible speed and leaves zero residue behind. And that supersonic pure water stream leads us directly to this magical number, 20. Because soft materials yield so easily, suppliers don't just cut one sheet at a time. No way. They do what's called stack cutting. They will literally layer 10, 15, even 20 sheets of foam or rubber on the cutting bed all at once. And the pure water jet slices through the entire stack perfectly in one go. This means they're turning out thousands of parts in a fraction of the time, which makes it the absolute ultimate setup for bulk buyers and wholesalers. Finally, we arrive at Section 6, the audit. Now, what's really interesting about this next part is how we put everything we've learned into practice with an actionable supplier checklist. Because knowing what the tech can do is really only half the battle. To actually optimize your sourcing strategy, you need a strict, structured evaluation process for every single RFQ you send out. You need to focus on these 3 strict auditing steps: defining your edge quality, verifying machine calibration, and analyzing abrasive consumption. Let's break down exactly what these mean for your bottom line. Okay, here is the direct commercial translation to make sure you aren't getting scammed. First, don't overpay for precision. Waterjet edge quality ranges from Q1, which is pretty rough, to Q5, which is flawless. If the part is just an internal structural bracket, specify Q3. Only ever pay for Q5 on visible, high-tolerance edges. Second, if you're sourcing massive plates over 3 meters, you've got to ask the supplier for their calibration logs. The thermal expansion of the machine's steel bridge over those long distances can totally ruin your tolerances. And finally, abrasive garnet accounts for up to 60% of a supplier's operating cost. So if a quote comes in suspiciously low, that is a huge red flag. They might be using cheap, recycled abrasive, which is going to leave you with pitted, terrible edges. Protect your project by knowing these tricks. Well, we have covered a ton of ground today, from cold-cutting thick steel to stack-cutting foam, all while locking down exactly how to maintain complete commercial transparency. So I want to leave you with this final, somewhat provocative thought to take back to your team. Look at the raw materials you rely on today and think about what you might need tomorrow. Is your supply chain versatile enough for 2026? Are you truly maximizing your yield? Or are you locked into rigid, heat-based processes that are secretly costing you time and material? Really think about it and start auditing your supplier ecosystem today. Thanks so much for joining me on this explainer, and I'll catch you next time.